Hi, Year 11s. Let's finish chapter 14. Before you get on to this part 14e, when you simplify that following expression, it is important that you master or have the formula from 14d, the addition formula, to understand the proofing of what the relationship we're going to look at today. So today we're looking at a sum of cos and sine. And what we'll do is we can simplify that as just a cos function or an alternate way as a sine function. This will allow us to uh, graph the function, determine the new amplitude and the intercepts. So R as a coefficient is a r for radius. It has a new value, which is square root of a squared plus b squared, which is using those a and b coefficient. Now r is going to be positive, so keep that in mind. And that alpha, which is a horizontal translation, is defined as cos of alpha and sine of alpha, respectively, as those ratios. Um, with the sine is you have a sine function. The radius is the sine, but what you'll notice is this: it's a new angle beta, which is a plus, and now the reverse of the previous relationship. We have sine of beta first and cos of beta second. Let's look at the proofing. So to do the proofing, first we define the radius, and then we consider a point P. That is what we define has the respective coordinates. So it's A and B, but they're all divided by R. That define uh, uh, and we define following that the distance from the origin. So we use Pythagoras theorems. It's OP squared. We simplify that and we find out it's equal to 1. So P now is on the unit circle. So its coordinates can be defined as cos and sine of an angle alpha. For the second relationship, we can define as sine of beta and cos of beta. Once we have the coordinates in terms of alpha, what we do is we go back to the original relationship. To get the ratio a over r and b over r, we factorize the radius r. We substitute a over r and b over r by cos of alpha and sine of alpha. And then should look familiar. This is using the addition rule, cos of x minus alpha. And here is the proofing for the first relationship. And we can have that similarly for the second one when we define that those ratios as sine of beta and cos of beta. You will have a similar proofing and you'll substitute with sine. Let's look at the first example. So here is the formula that we just looked at. This is the example. What you need to do is re-express that into a concise form. Then we can determine the range and find the minimum, the maximum and minimum for that function. So pause the video and have a go at this on paper with a pen, and then I'll continue. All right, so let's continue with this. What we do is determine A. So you find the value of A and B, which are the respective coefficients. So 1 and negative, don't forget the negative sign. It's negative root 3. We calculate the radius, which is 2. We can factorize that and find that cos of alpha is 1 over 2. Sine of alpha is negative root 3 on 2. The sign will determine which quadrant you're in. Those are exact values you need to know. So alpha is negative pi on 3. So f of x can be simplified as 2 cos of bracket x minus negative pi on 3, which is plus pi on 3. You can see now that the function has a coefficient of 2, so we can determine the range. It's -2 to 2, the maximum is 2, and the minimum is -2. So we keep this function for the next example, because I'm going to skip through a little bit quicker. So using the same function, in the next example, you have an equation over that domain. The domain is very important. So now the left-hand side represents that function that we look on the previous example. So it's 2 cos of x plus pi on 3. We make it equal to 1. We make cos the subject. Now, when you have an equation and you notice the period is 2 pi, over this interval, you know you should have in general two solutions. So here we have cos of x plus pi on 3 is 1 over 2. Determine one solution in the first quadrant to be equal to 1 on 2, which is pi on 3. Also, you will have 5 pi on 3, which is the fourth quadrant. And you will also have to include this one in a second. So now keep that in mind. I told you there should be two solutions. But here we're going to include a third one. That is why in general you should use the general solution. But let's say we include the third one. Now that expression was x plus pi on 3. Now we make x a subject. And we end up with those three solutions. Normally you would have two. But notice that 2 pi is also on the domain. So on this domain, because you have a particular solution of 0, if you add 2 pi, you get the next solution, which is 2 pi, which is also included, both of them on the boundaries. So in this particular situation, you will have three solutions. In general, you will have one per period, so you should have two in general. All right, last example. So you have your expression. Okay, and you need to express it in terms of sign. Now, if you were to use the formula, I would just rearrange it to make cos on the left-hand side, and then determine the radius r and the a over r and b over r ratio to determine the angle beta in the formula. Now, here you have a 2x, which is kind of a different. You can't really use the formula to express that. So what we'll do is we'll make it equal. And then what you do is instead of manipulating the left-hand side expression, what we do is we're going to look at the right-hand side, use the addition formula for sine, substitute into here, okay? And because it's going to work for any values of x, what we do is we substitute, we choose two values that are distinctive to cancel out either the sine or either the cos on the left hand side, and the right hand side will simplify to those ones as well. So now what we then end up is two equations in terms of r and alpha, two equations, two unknowns. It's two simultaneous equations that we're going to solve for r and alpha. To do that, first method, one method you could have used is use the trigonometric identity, cos squared plus sine squared equals 1. Another way you could have done is eliminate r by doing the division, or write it as a fraction to get the tangent expression. So here, let's go back to the method that the textbook used. We do the sum of the squares. That will be equal to 4. So we can r is equal to 2 because we only keep the positive solution. We substitute into 1 in the two equations. And we can determine that alpha is equal to negative pi on 6. So the expression is equal to this equality in terms of sign. We have determined r and alpha, which is negative. All right, and that's it for chapter 14. See you later.